Imagine you're building a Lego tower on a fluffy marshmallow. What happens? Squish. Now, imagine doing that with a multi-million-dollar highway. Not so funny anymore, right? In construction, we don't just dump dirt and start building. We have to compact it, squeeze out the air until the ground is as hard as a brick. But how do we prove the ground is solid if we can't see the air gaps? Welcome back to Southasia Materials Science. Today, we're playing a high-stakes game of Fill the Hole. We're talking about the field density test by sand replacement. It's low-tech, high-precision, and it's the only thing keeping your house from sinking into the earth. When big excavators move soil, they introduce air. If we build on that fluffy soil, the weight of the building will eventually push that air out. Engineers call this settlement. We call it a disaster. To prevent this, we need to find the dry density. We need to know exactly how much solid stuff is in every cubic centimeter of that ground. But there's a problem. You can't exactly cut a perfect cube out of the earth to measure it. It just crumbles. The solution? We dig a messy hole and then use some very special sand to tell us exactly how big that hole is. Meet our secret weapon. Standard sand. This isn't your average beach sand. This is graded, dry, and uniform. It's the Goldilocks of sand. It flows exactly the same way every single time. The step-by-step magic trick. The extraction. We lay down a metal plate and dig a hole about 15 centimeters deep. We save every single speck of that soil in a bag. That's our mass. The pour. We place our sand cylinder over the hole and flip the switch. The math of the void. By weighing the cylinder before and after, we know exactly how much sand fell into the hole. Since we already know the density of our standard sand, it tells us the volume of that weirdly shaped hole we just dug. Now, we head to the field desk. We have the weight of the soil and the volume of the hole. Step 1. Bulk density. This is the soil's weight, water and all. But wait, water is a liar. It adds weight but provides no structural support. We need to dry a sample of that soil to find the moisture content. Step 2. The truth, dry density. If that number matches our laboratory gold standard, the contractor gets a thumbs up. If not, bring back the rollers. We're squishing it again. In an age of AI and nuclear gauges, why are we still playing with sand and cylinders? It's honest. You can see it working. There's no black box algorithm. It's tough. It works in stony soil where fancy sensors get confused. It's South Asian proof. It's cost-effective and works perfectly from the heat of Rajasthan to the humidity of Dhaka. So the next time you're driving on a perfectly flat road, remember the humble sand cylinder. It's the invisible ruler that makes sure the world stays under your feet and not over your head. If you want to see how we test if these roads can handle a 40-ton truck, stay tuned for our next video on the standard Proctor test. Hit that subscribe button, leave a comment about which test we should cover next, and as always, stay curious and keep building.